this lesson gives some examples of algebraic problems. Here are some words of advice. First of all, read the problem twice. Once to figure out the general setting, and another time to pick out the important information. Second, organize your data, assign a variable for the unknown, write an equation, solve the equation, check the solution to see it's reasonable, and finally give a formal answer. Make sure your answer is answering the question that's being asked. Before we begin, there are some useful facts to note for any geometry-related problems. This is just a quick overview, but if you're interested in the reasoning behind these properties, please do not hesitate to ask. First, we've got the Pythagorean theorem, which tells us that for any right-angled triangle, the legs, which are the shorter sides, each, if squared and added, will equal the same as the hypotenuse squared. There are several proofs for this. Next, we know that in a triangle, the sum of all the angles is 180 degrees. One way to look at that is if you had parallel lines like this, you can see that this angle here is the same as this angle here because of the parallel lines, and this angle here is the same as this angle here, so we know that they all add up to 180 degrees, all three of these angles. That's one way. There are other proofs as well. Further, when you have a rectangle, you should know that the length times the width gives you the area, twice the length and twice the width give you the perimeter. There's some circle formulas you can use. You should know that the area of a circle will be pi r squared, and the circumference is pi times the diameter, because pi actually means how many diameters fit into the circumference. So pi's definition is how many diameters fit into circumference. You can manipulate this formula and you get there. Finally, remember that when you're dealing with a trapezoid, to find its area, you need to take the average of its bases multiplied by the height. Here's a geometry problem. The second angle of a triangle is 3 times as large as the first angle. The measure of the third is 10 less than that of the first. How large are the angles? We need to find the angles of this triangle. We know all three of them will add to 180, but let's just note down the important information. We have the first angle, second angle, and third angle. Notice that all of the sentences refer to the first angle as a comparison. So we should call that first angle x. And so here we're noting what our variable is. They tell us that the second is 3 times as large as the first. So second is 3 times as large as the first. And the third is 10 less than that of the first. So 10 less than the first. We have these three angles. We know they add to 180, and therefore we can make an equation to do so. We can then solve this equation saying there's 1x, 3x, and another x, that's 5x minus 10 is 180. Add 10 to both sides, and you get 190. And then take 190 and divide by 5, gives you 38. So you know one angle is 38, the second angle is 3 times 38, and the third is 10 less than 38. So you would answer a final answer. First angle equals 38 degrees. Second angle equals 3 times 38, which is 114. And third angle equals 38 minus 10, which is 28. degrees. You could also have a number value problem. So here we've got a bill that's totaling $2.55. Cashier receives 15 coins consisting of dimes and quarters. How many of each denomination of coins did the cashier receive? So we don't know the dimes and the quarters. So we have the number of dimes and the number of quarters. You could set it up so that you see that, okay, the number of them times their value in, say, dollars equals the total dollars. So you could say, well, we don't know how many dimes we have, so let's call that X, but we know that each dime is 10 cents, so that tells us that all of the dimes will give us this much money. Now the quarters, we don't know how many of those we have either, but we know we have 15 coins in total. So if we had 15 coins in total, and say, for example, 5 of them were dimes, how many quarters would we have? We'd have 10. How did you find that? Well, you went 15 minus 5. So if we don't know the dimes, we can in general say 15 minus X. So we have the value to be 25 cents. So 25 cents times however many quarters we have will give us the value of the quarters. In total, all together, we're going to get $2.55. So here we've got an equation. So this is just a result of ordering the data in this particular way. You can order the data in any way you like, as long as you result in an equation that makes sense, obviously. So now you can go ahead and try and solve this equation. So you've got 10 cents times X and 25 cents times 15, which is $3.75 minus 25 cents times X. And you can go ahead and solve it. So we've got 10 cents minus 25 cents gives us negative 0.15x. That's combining like terms. Let's just subtract this 3.75 as well, resulting in 2.55 minus 3.75, giving us negative 1.2, and divide both sides by negative 0.15, giving us X to be equal 8. Well, that's a nice number, isn't it? It's not always going to be a nice number, but in this case, number of dimes and quarters should be. So this tells us that X is 8, which was the number of dimes. So you would say that the number of dimes is 8, and number of quarters is, and you know that that's 15 minus 8, which is 7. You can check your work. You can go 8 times 10 cents and 7 times 25 cents and see if that works out to this total. Another problem would be a numerical problem. Quite often, you'll have consecutive integers here. Remember, regular consecutive integers skip by 1. Even or odd consecutive integers will skip by 2s. So here they want us to find 2 consecutive even numbers so that 3 times the first plus twice the second is 254. So let's let our integers be these integers. So X be the first, and so the second would be X plus 2, because an even number will skip by 2. Now they're telling us 3 times the first, so 3 times X plus twice the second is 254. So that's a direct translation left to right. Now you can solve it. You get 3x plus 2x plus 4 equals 254. 5x plus 4 equals 254. Subtract the 4 from both sides. You get 5x equals 250. Divide by 5, and you get 50. Now what does that mean? Plug it back into what you labeled the variables as. So you know the first integer is 50, second integer is 52. Another problem would be to do with percents. So remember, you can use this proportion relating the percentage to a part of and out of the whole in the bottom. So here you have average price of a one-bedroom apartment in BC rose from this much to this much over a year. What percent increase was this to the nearest tenth of a percent? When they ask about a percent increase, they're not asking about what percent is this out of a total. It's how much is the difference out of the original. So difference out of the original is what percent increase or percent decrease will be. So let's see, how much did it actually rise? Well, it rose 121 minus 115, so 6,000 is how much it rose. Now, when you do percent increase or decrease, you're always relating to the original amount because you want to see how much it's gone up by in comparison to the original amount. Now we can just find that as a percentage. So take 6,000 divided by 115,000. That gives you 0.052 and so on. Let's round that there. Well, let's give it one more, 17. So when you turn it into percent, you can just multiply by 100%, and that turns it into 5.22. So that is the percent increase. You could also have investment problems. These problems often start with the total investment splitting into account 1 and account 2. Here, let's see what happens. Peter invests some money at 3.5% and $5,000 more than 3 times the amount at 4%. He earns interest on both of these, and together he gets $1,440 in the year. How much did he invest at each rate? We know that to find the amount of interest, we take the principal amount times the rate times the time. In this case, our time is just 1 year, so it's just a 1. So really, we're just taking the percentage times the rate. The principal times the rate. So let's look at the amount that he's put in. How much has he put into account 1 and how much has he put into account 2? Well, he puts in one amount here, so let's call that X, but then he puts in 5,000 more than 3 times the original amount that he put into the first account into this account. And that's just taken from this part here. So we know that if we take 3.5% written as a decimal divided by 100 to get rid of the percent sign times X plus 4% of the other amount that has been described to us, that should equal a total of this much interest. So here's another way. You could have written this as a table with account 1, account 2, and you could have had the percent times the amount is equal to the total. So there's many ways of organizing data. I just want to show you a few different ways. This video is not to show all the possible ways, but it's giving you some options. So eventually you get to this formula or this equation that you have created, and we can go ahead and solve it. Collect like terms. Subtract. So you get 1440 minus 200 gives you 1240 divided by 0.155, and that gives you 8,000. So that tells us that we want to put $8,000 in the 3.5% account, and now we have to figure out how much money was put into the other account, which is 3 times 8,000 minus plus 5,000, which is 29,000. So this person put way more in the higher percent account. They wanted to take more of a risk. Here's another example. We've got a mixture solution problem. You can do this in various different ways. You can either use a table or a diagram like we just used. Let's use a table this time. So we've got total of 16 liters. How much pure antifreeze must be added to a mixture of water and antifreeze, that is 18%, to make a mixture of 20%. So they're saying how much pure antifreeze. Well, what's pure antifreeze? Well, this is 18% antifreeze. This one's 20% antifreeze. So how much 100% antifreeze is added to 18% antifreeze to make 20% antifreeze? So you're trying to strengthen the antifreeze that you already have. So we want our percentage multiplied by our amount of the stuff to give us the antifreeze that we have. So the percentage for 100 is 1 as a decimal, and the other ones are clear. So they're saying how much of this, so we don't know it, so we call it X, added to 18% to make 20%. We know that we have a capacity of 16 liters max. So that's our total amount that we can possibly have. And so we want to fill the radiator, and that also implies that that's how much total we have. So we know that the rest of this will have to be 16 take away X. So 16 take away whatever we've added. This way we're choosing X to be the amount that we're adding and the other amount to be the rest. So if we multiply that through, we've got antifreeze, which is 1X, which is just X, and then mixed with the diluted amount, 18% of 16 minus X, giving us 0.2 times 16. Now we know that this amount of antifreeze plus this amount should equal this amount, and there's our equation. So we can solve that. X plus 0.18, 16 minus X equals 0.2 times 16. So we go ahead and solve this here. By now you should have the solving down, so I'm skipping a few steps here. But at the end you should get 0.39, which would imply we only need 0.39 of a liter of pure antifreeze to fill it up. Now, does this answer make sense? Well, we're only raising it from 18% to 20%, and we're adding pure stuff. So that does make sense that a very small amount should be added to fill the radiator. Finally, we also have motion problems. Now, here are some possible situations for motion problems. You could have items growing apart, coming together, or having the same distance. So you could have either total distance or same distance problems. In general, you're using the formula rate times time equals distance. So let's take a look at this problem and see what kind this one is. Coast Guard patrol boat travels 4 hours on a trip downstream with a 6-mile-per-hour current. So this guy is going downstream 4 hours, and the current is 6 miles per hour. He's going with the current. The return trip takes 5 hours, and the current is the same, they're assuming. So find the speed of the boat in still water. So if there was no current, what speed is his engine revving at, is what the question is. So we've got with the current as one option, and against the current as another option. So one way you could organize your data would be to say, well, what's the rate? What's the time traveled, and what's the distance for each component? And then you can compare components. So you can see that it's this case here where you go up and down. So we know that the distances are the same. So that'll help us make an equation between one component and the other. We'll know that they are equal. So let's go back to the rate. Now remember, for rate, you've got still speed and current speed. So when you're moving with the current, you've got your predominant speed plus the current. But if you're going against the current, you've got your predominant speed minus the current because it's slowing you down. Now, your predominant speed is not always x. In this case, it is because that's what they want. But maybe they want the rate of the current. So remember that no matter what, this x could change, but your first component of your rate should be the predominant speed. So hopefully the boat is the predominant speed, because otherwise it shouldn't be in the water. So we've got with the current, x is the rate of the boat in still water, plus the current speed, which we know is 6 miles per hour. Against the current, you have the predominant speed of the boat in still water. So this is x minus the current. We know one travels 4 hours, one travels 5 hours. So that gives us the proper expressions for the distances. If you go 4 hours times the rate like this, you get this amount. 5 hours times the other rate, you get that amount. But those amounts should be equal because we know that the distance is the same because he went there and back. That leaves us with this equation. We can solve this equation. Subtract 4x, you'll get x on this side. Add 30, you'll get 54. So you know that the speed of the boat in still water is 54 miles per hour.